Yeah, so I'll give a quick contextual introduction, and then we'll pass on to Shay to do some architectural diagrams, and then a code demo from Julian, and finally Leo's going to be talking about some cool algorithmic things. So basically what we've been looking at is what's known as multilateral trade credit set-off, also known as obligation clearing. And essentially, you'll look at a trade network. So businesses are trading with one another. They have accounts receivable, accounts payable, businesses they owe, businesses who owe them. And instead of having to settle with real money, you can just identify chains and cycles in that trade network and clear the debt. So another component to that, which we haven't really explored yet, but we intend to, would be liquidity injection to balance even more of those debt cycles. So essentially what this does is liquidity savings for businesses without having to resort to any payment and fiats.
You would have one agent who would be able to upload almost their obligation, right? So the creditor is uploading an invoice that's saying, you, agent B, owe me this amount of money. Now, agent B needs to kind of confirm, or we feel that agent B needs to validate that that is in fact an invoice that should be processed in the computation of pathfinding, or else people could just spam out invoices and you wouldn't really get debt clearing. So the way we ideally wanted to do that was by having the first agent kind of signal the second agent and then countersign some atomic entry into both of their source chains. This isn't public. The point of this wrangle is to avoid the financial data being public. And I think the beauty of going that route will be very clear when Leo starts explaining the pathfinding algorithm he's been investigating. So somewhere around midnight this time yesterday, we realized that countersigning just isn't going to happen in the short amount of time we have. It's something I fully intend on sinking my teeth into. But we decided to try and implement a simpler, just pushing to a DHT, having public entries for now that we can traverse in our computations for paths and identify which of those can be cleared. And at the end of that process, that would be returned to all the users and they will see, oh, I was lucky enough to have this much debt cleared, because it's not, well, this much credit cleared. It's not, you will only clear some amount of it. And it's an optimization strategy, not a way of like making imaginary credit or imagining credit to disappear rather. So we went for this like public approach where you're just putting things into a DHT. It's simply being created by agent A and then updated by agent B. Agent B is saying, yes, this is verified. So its approved status goes to true. When its approved status is true, it is ready for computation.
One thing that struck me as very interesting is that very easily I could have this type of search mechanism in order to easily connect two agents. So it's somewhat of a network discovery between those that install the same application. So it was pretty quick to do. And the idea here is that the user fills in their details about their obligation, sets a time date, and that creates the obligation. And well, at this point, we were hoping to get these agents to trigger a signal to the other agents that, hey, you have something you have to sign on, to countersign on. And so at this point, the user would countersign this and be available for the algorithm. So as you can see, that's pretty much it as far as the application goes. Very, very basic stuff. But one thing that stood to me is how doable it is to do Holochain apps. I mean, you get this first bump of conceptual, at least for me, that comes from a blockchain world. There's this little concept gap that we need to fill in first, but after that is done, it's actually pretty standard and useful and helpful to build applications on it.
As any given agent in this debt clearing system is, we're trying to find debt loops that begin and end with ourselves. And so each agent at any time can continually run a function to try to find more and more data about loops that they might be they might exist within. And so you start out, say you're agent A, and you have a debt to agent B. You ping agent B, you ask them for records of creditors that they have. So they send you information about their debt, if they choose to. And agent A then takes that information and records it as metadebt. So they have agent B as can be saved as metadebt, and agent C now can also be saved as metadebt with a trail going back to agent A. And you can keep pinging agent B, and now you can also ping agent C for information about their debt. And it essentially keeps running until somebody finds a cycle. As soon as you become your own meta creditor, then you have found a cycle, and you notify everyone in that cycle, I found one. Would you like to clear this debt? And then there's a process for agreeing to that clearing. So the flow looks kind of like this. I'll request obligations from some creditor or meta creditor. I'll add those new meta obligations, meta debt, to my list of meta debt, and then see if I've found myself. And if I have, then see if I can clear that debt.